Hello, good day everyone. So we have here an example for the torsion. So, ayan, isang example lang tapos ma-cover nyo naman ata lahat na formula na gamitin dito. So we have here the girder is subjected to torsional movement from the loads on the cantilever frame. The following factored forces are computed from this beam. We have factored moment mu, the factored shear Vu, and then the factored torque T sub U. The girder has a width of 400 mm and an overall depth of 500 mm. The concrete cover is 40, and then we have the centroid of longitudinal bars 65 mm from the extreme fiber concrete fibers, and then FC prime 20.7 and the FY 415, and for the stirrup we have 275 with 12 mm stirrups, diameter pala. So first we have to determine the spacing of the transverse reinforcement due to VU alone, or the stirrup reinforcement, yung spacing po. So since this is for the VU alone, ang tanong, so we will go back to the shear in beams, no? So we have the VU. So first, number 1, VU. Ilagay muna natin yung mga given. We have the MU 300 kilonewton meter, and then for the VU factored shear, naka-factored na yan, no? So meaning ang factored natin, kunyari VU, it is equal to VN, no? Ganon. For VU we have 247 kilonewton, and for the torque we have 40 kilonewton meter. For FC prime we have 20.7 MPa, and for FY we have 415 MPa. For number 1, we need to find the spacing S for VU alone. So we know that we have the formula for VU as VS plus VC, or the VN is equivalent to VS plus VC, right? So ayan ang gagamitin natin. Since meron tayong VU, ito lang yung gagamitin natin. Since yung VN naman is equivalent to VU, ito, VN is equivalent to VU over V. So ito yung magiging equation nya. Erase natin ito. So we have VU, we have 247, but we don't have yung phi natin is 0.75 for shear, but we don't have the VS and the VC. But we know the formula for VC, or the shear provided by the concrete, which is equal to 0.17 lambda square root of FC prime BW D. So we will draw first the section, and we have the width of the beam or the girder that is equal to 400 mm, and for the overall depth we have 500 mm. For the effective depth, how much ayan? Since from the problem, it says that the centroid of longitudinal bars of the girder are placed 65 mm from the extreme concrete fibers. So from here daw po, centroid up to the extreme concrete fiber, which is equal to 65. Therefore, yung din natin is 500 minus 65. We have 435 mm. To compute for the VC, we have 0.17. Lambda natin is 1. If hindi sinabi kung anong klaseng concrete siya, since walang sinabi, we will assume that it is a normal weight concrete. So we have FC prime na 20.7 and then the BW, which is equal to 400, or just the width of the beam. And then we have the D, which is equal to 435. VC is equivalent to, we have the value of VC, that is equal to 134,580.8734 Newton. You can just store it in your calculator. And then to solve for the value of VS, it is equivalent to, or you can substitute the value here in this formula. 247 times 10 raised to 3 is equivalent to 0.75 VS plus 134,580.8734. VS is equivalent to we have 194,752.46 Newton. Okay. So we will solve for the value of the spacing na. We know that we have the VS is equivalent to AV times FYT D all over S, right? So to solve for S, ito, babalik rin nyo lang. I mean, ipagpapalit nyo lang. So we have S and then we have VS. And of course, first, so solve muna natin tuloy. We have AV. So wala naman sinabi kung ilang legs. So we will assume it to be to have na merong 2 legs. Pi over 4, and we have 12 squared times 2. Okay. And then we have the FYT, which is equivalent to 275 times the effective depth 435. And then the VS is the computed value for VS. We have 194,752.46. So the value for the spacing is equivalent to 194,752.46 138.94 mm. Or say, wait lang. Compare muna natin yung VS. Compare natin siya sa 1/3 square root of FC prime BWD, which is equal to 1/3 square root of 20.7 times BW times 435. We have the value of 263,884.07 Newton. So since yung value ng VS natin is less than the amount of this equation, so let's say less than, so the value of S max will be equal to D over 2 or 600 mm. So for D over T, we have 435 divided by 2. We have the value of 217.5 mm. So choose the smallest among the three. We will choose the smallest, of course. So we have the value of S that is equal to 138.94, or let's say that it is 130 mm. The smaller the better, no? Kapag spacing, always round down. For number 2, determine the spacing of transverse reinforcement due to TU alone. We have the value of TU that is equal to 40 kilonewton meter. Kilometer. So first step to solve for the spacing for transverse reinforcement in torsion only will be, first is to check if the torsional reinforcement is required, no? So if we have this condition, we have the TU or the factor torsion is greater than or equal the phi TTH or the torsional threshold. Yan masasabi natin that the torsional reinforcement is required. Ano? Pero kapag TU is less than the phi TTH, not required. Ganun lang kalala, no? So yan yung first step. Yan, wag ko nang tanggalin. So first, we have to solve for the value of TH or the torsional threshold, na merong formula na kapag naka-phi TTH, so we will be putting phi also in the equation. 1/12 lambda square root of FC prime times the value of ACP squared all over PCP. So ano itong ACP na to and then the PCP? So from your discussion earlier, meron tayong section. Saan natin ilalagay? Dito na lang sa katabi. Ito. Meron tayong section and we have here 400 and then we have here 500. Ano? For the ACP, anong tawag dito pag ACP? It is the area enclosed by outside perimeter of the concrete cross section. So ibig sabihin, kung ito yung outside perimeter, yung kabuuan ng cross section na to is the area of the cross section ACP. For the ACP, it is just the area of the gross cross section, which is equal to 400 times 500. Wherein yung PCP naman po is just the outside perimeter of the concrete cross section. So we have dalawang 400 for the BW. Ito, isa, dalawa. Plus dalawang 500. Okay. So tayo, lagay na lang natin dito. Dali lang naman siya. So we have phi 0.75 for torsion, 1/12 lambda is equal to 1, FC prime 20.7, and then for the value of ACP we have 500 times 400 squared all over 400 times 2, we have 800 plus 500 times 2, we have 1,000. So the value for TTH is equal to, we have 6.319 kilonewton meter. So from this value, we can say that the TU is greater than the phi TTH. Ano? Ibig sabihin, yung torsional requirement is required. That would be the step 1. No. For the step 2, ito yung 1. Lagyan natin na 1. For step number 2, we will calculate the sectional properties. Ganito kasi yon. Drawing natin ulit para wala tayong problema. Dito na lang ata. Kaya na ata yung dito eh. Ito. So, this would be the cross section of our the beam cross section. Ayusin lang natin para pantay. Charot. Oops. Dapat pala di ko na inayos, no? Oops. Yan. Medyo pantay naman. So, of course, meron tayong stirrups dito na nakapalibot. Ano? Yan. Tapos, ayan. Dublin lang natin para maganda. Ito, dapat kailangan magaling kayo dito mag-drawing. Para damang-daman yung pagdi-design. So, meron tayong longitudinal bars. Ayan. Parang ganun. Okay? So, meron tayong BW 400 and then 500 na height. Move lang natin to dito. And then, yan. So, from our step 2, we need to calculate for the values of A sub OH, E sub O, and then the pH. Ano-ano tong mga to? For the A sub OH, that would be the ang tawag dyan, shall be the area by the enclosed stirrup or center line of the stirrup. So, itong A sub O. Ano? Kasi yung A sub OH is just the 0.85 or the 85% of A sub O. And then, meron tayong baliktad. The A sub O would be the 0.85 of the A sub OH. Yan. And then, the A sub O is just the area of the enclosed stirrup. Sabihin natin ito. Ito, sa gitna tayo magkukuha ng dimension, no? Sa gitna ng stirrup, we have the x1. And then, sa gitna ulit, we have the y sub 1. So, the A sub OH would be x1 times y1. For the perimeter h, or the tasing h9 is the hoops, no? So, perimeter would be equal to 2 times the x1 plus the y1. Yan. To get that, of course, kailangan natin mag-analysis, no? First, kumpitin lang natin. Yan. I-move ko na to para kumasya. For x sub 1, yan. Isa-isa natin yung corners nito. Sabi, sa problem, merong sinabi na the concrete cover is 40 mm. So, kung itong cover na to until dito sa pinakalabas o sa pinaka-face, ito kasi sa gitna, no? Sa face ng stirrup is equal to 40 cc, 40. Tapos, yung hoops natin or the stirrups is equal, or yung diameter nito is equal to 12. Since ito naman is nakatutok sa gitna daw po. Nakatutok siya sa gitna. Ito. Ibig sabihin yung kalahati lang yung isama natin, no? So, ibig sabihin, ito is just 40 plus 12 over 2. Ano? Ibig sabihin, we have 40 plus 12 over 2 or 6 is equal to 46. No? Ito, para parehas na yan, 46. Same dito. To get the value of x1, so we have 400 minus dalawang 46. For the x1, we have 400 minus 46 times 2. We have 308. And for the y sub 1, we have 408. Okay. So for a sub OH, we have 308 times 408. And this is equal to, wag na. Diretso na natin. Pwede naman. 308 times 408. We have 125,664 times 0.85. We have 106,814.4 mm squared. For the value of perimeter, meron tayong 308 plus 408 times 2. 1432 mm. Saan natin to gagamitin? Of course, to get the spacing of the transverse reinforcement due to torsion alone. Okay? So, meron na tayong parameters. So, next is to check for the adequacy of the cross-section. Nandito pala yung step 2. Ito. For 3, check for adequacy. Adequacy. Meron tayong equation na kailangan nating i-compare for us to solve or for us to say that the cross-section is adequate. So, we have square root of VU BWD squared plus TUPH all over 1.7 A sub OH squared times squared. So, this equation must be less than or equal to phi VC BWD plus 3.66 square root of FC prime. Unahin natin itong may square root. For the square root of VU, meron tayong 247 times 10 raised to 3. BW, 400. For the D, 435 squared. For TU, meron tayong 10. 40, I mean. But 10. 40 times 10 raised to 6. For the PH, meron tayong 1432, I think. 1.7 A sub OH, we have 125,664. And then squared. So this would be equal to 2.563. And then for this value naman, phi, we have 0.75. VC, computed na yung VC natin, no? Yung kanina. Same lang yun. Yung lalabas po. 134,580. 0.734. Tama. 8734. All over BW 400 for 35 plus 0.66 square root of 20.7. This is equal to 2.832. So from this value, itong dalawa, we can say that 2.563 is less than 2.832. Therefore, cross section is adequate. Okay. Diyan, checking pa lang tayo ha. Wala pa tayo sa spacing. So next step would be the spacing na. So actually kung ano na kayo, kung ano tawag diyan, confident kayo na mag-adequate ito, and then kailangan ng torsion reinforcement, edi skip na kayo dito. Punta na kayo sa spacing. Pero I suggest na i-solve nyo pa rin for the purpose na, of course, tama yung ginagawa nyo. Let's proceed for the number 4. Calculate the required spacing. So we have the value or the formula for Tn, that is equal to 2 times A sub O times AT times FYT over S multiplied by cotangent theta. Okay. So for the value of Tn, it is just equal to Tu over phi. No? So, palitan natin ng Tu over phi. So, itong phi natin ilagay natin dito. So, rearrange the equation. We have the value of phi 2A sub O AT FYT over S, or I mean over Tu cotangent theta. Ano? So, obviate natin yung spacing. We have phi 0.75 times 2 times A sub O, which is equal to 106814.4. Ito. Times 80. Ano yung 80? It's just the area of transverse reinforcement. With on one leg only lang, no? 112 squared times 1. One leg only lang yan, 80 ha. FYT we have 275. All over TU, which is given 5 raised to 6. 40 times 10 raised to 6. So for the value of spacing, it is equal to 0.75 times 2, 106814.4 over 4. Over 4, 12 squared times 275 divided by 4 times 10 raised to 6. We have 124.6 mm. Or say 125 mm. I mean 120 mm. So yan na yung sagot for the value of, or for the number 2. For the last item, we have, ay hindi pa pala last. Isa pa. Determine the spacing of the transverse reinforcement based on combined shear and torsion. For 3, na tayong formula about dyan, no? So, determine the required spacing. For the combined, we have the S is equivalent to dalawang AS, wherein yung AS natin is just the value of one leg only. So, may multiplier tayong 2. So, all over the value of 280 times S na nasolve natin kanina plus AV over S. Okay. So, yung AV natin and AT is just the same, no? Magbabago lang yung mga number of legs. Kapag naka 80, just one leg. And for the EV, for the shear, yan, consider natin yung dalawang. So let's compute 2 times pi over 4, we have 12 squared times 1 all over 2 times 80 pi over 4 12 squared times 1 all over the S, wherein yung S natin is the computed S kanina na 124.6 plus AV na equivalent to pi over 4 12 squared times 2. Okay, wag kayong malito. And then the S would be equivalent to 138.94. Yung S kanina na na-compute nyo. Yan. For the value of spacing, it is equivalent to you have the value of S na 600 or 65.69 mm. Yan. For number 3. And then, for the last number, for number 4, additional longitudinal pangit ang sulat ulit. Additional longitudinal reinforcement, call this AL. So we have AL is equivalent to P sub H 80 over S FYT over FY and cotangent squared theta. Lahat naman na-solve natin. We have the PH that is equivalent to 1432 and then the 80 is equivalent to pi over 4 12 squared times 1 and then S, the S is just for the torsion only. We have 124.6 and also we have 275 and 415. Cotangent squared 45 degrees. For the A sub L, it is equivalent to, we have the value of 861.315 mm squared. So this will be the value of the additional longitudinal reinforcement EL. By the way, to type for this cotangent 45 degrees, you can input in your calculator na 1 over tangent, tapos maglalagay siya dyan ng parenthesis, automatic. Matatanong yan ng angle. So you can just put 45 degrees, tapos maglagay ka ng squared dito. So it is equivalent to cotangent squared 45. Okay? So yung cotangent is equivalent to 1 over tangent. So, squared nyo lang. Okay na yan. So, final answer. Ayan. Okay na. Screenshot for your reference. Number 1. For number 2. Number 1 pa lang. Ito. For number 2. Lakihan natin para maganda. And then for number 3 and 4.